So even though this is on a future lesson, lesson 90, we're gonna go back to page 49 and look at how to graph the trig graphs on the calculator because we'll need that for today's lesson. So go back to page 49. I already have the answer for 3A and we're gonna start there. So now I'm on my calculator, and the first thing we need to do whenever we're graphing trig graphs is press the mode button and make sure we're in radian mode. So I'm gonna move it down to that and press enter. Now, in this problem, it reads that we have an amplitude of 3, a midline of 2, and a period of pi. So when I go to y equals, I'm going to type in the function I found, which is 3 cosine buttons right here of 2x and then plus 2. Setting my window, my x values, if I want to see one period, always go from 0 out to the period value. So this is 0. And then I'm going to actually put in pi here. Looking at this graph, my minimum is -1, my maximum is 5. I can actually use those values, or I might use a little bit bigger numbers to see it. So let's try the graph button now. And if I did everything right, we see a cosine curve, and everything fits perfectly because I set it to just be that period length and then the min up to the max. So just to show, if I wanted to make this go out to 2 pi versus pi, I should see 2 periods of the graph. And maybe I'll just use the regular -10 to 10 just to kind of give a different view of the function. So here we see 2 cycles of the graph. Okay, and we see a little bit more in the y direction. Either way is really fine. I'm going to show one more graph before moving on to the next lesson. This equation here comes from letter C on page 49. So I have 90 cosine pi over 15x plus 100. Looking at this equation, we know that the period value is 30. So I'm going to go from 0 to 30 if I want to see one cycle of the graph. One thing I didn't do on the last one, I can change the x scale, and sometimes it's nice to divide the period by 4 because then you get those 4 different spots along the way. So 30 divided by 4 is 7.5. My min and max values, if I look at my graph, are 10 and 190 for this problem. So I'm going to probably go from something like 0 to 200 just so I can see the x-axis here, and then I press graph. So this shows me that for those qualities that were given in the question, the graph does look good. So we did another graph in lesson 89, but I actually can cover those topics just in this lesson, lesson 90, so we're going to go to today's lesson, lesson 90. This lesson is on regression, which, if you remember, is basically when we type the numbers into the stat menus, and then from there we can find the graph. So this says the process for finding a trigonometric regression, sine reg, is similar to finding a linear or exponential regression. The resulting equation from this type of regression is in this form. So a sine bx plus c, it's slightly different than when we write the equations. If you notice, the parentheses is in a slightly different spot. You don't have to worry about that too much. You're not going to have to identify phase shifts from this, which would be the only thing that would change. Trigonometric regression should be used when the scatter plot shows data that is periodic in nature. So whenever we see something that's fluctuating and going up and down, that's a trig graph. After choosing sine reg, you should see the menu here. We're not going to make any changes. We're just going to leave L1 and L2. We're not going to change the iterations or anything like that. Why is there no cosine regression? How can a sine regression be used to model data that more closely resembles a cosine curve? Basically, we can just do a horizontal shift in those cases. So you're never going to get a cosine regression. Basically, just shift sine over so it ends up where cosine is. So here's our first table. It says the temperature of a chemical reaction changes during the reaction. The temperature was measured every 2 minutes, and the data is shown in the table below. So why does it seem like this data might be periodic? We're going to create a quick scatter plot using your calculator to verify. So the very first thing we have to do, and I'm going to go over to the calculator now, is type these lists in the stat menu. So here we're gonna start recording. So I'm gonna go to the stat button once I turn my calculator on, and I'm going to go to edit. I do have numbers in my last list, so I'm just gonna quickly enter them so they go away. And then I'm going to start typing in those numbers. So my first one is 0, and then 2, and I'm not gonna have you watch me type in all these numbers, so you can type them in from the table, and then we'll come back. So now that I have all of my numbers in my lists, I need to go to y equals. I'll clear out any functions that are there, press enter to turn my plot 1 on, and then we use zoom 9, and that's going to create a scatter plot. So I see this pattern, it looks like it's doing some sort of a trig pattern, and that tells me that I want to use a sine regression. So I'm going to go to the stat button, over to calculate. I see my linear and my exponential, which I've used already this year, and way down here is sine reg, so this is the one I want to choose. From there, we're just going to leave the iterations at 3. That's not really a big deal. Our lists are correct. We're not going to try to guess what the period is, and we're not storing the equation anywhere, so I'm just going to press calculate. So I get these different values, and we're going to plug them into the equation. So I'm going to go back to the lesson now. So my scatter plot looked like this. It went up and came back down and then back up again. So I see that pattern. It looks like it's probably going to start coming back down again, and that tells me to use a sine regression. So when I use that regression, I end up with the following equation. I need to round to the nearest tenth. So I have 3.9 for A, sine the B value is 0.4, and then x minus 0.7. And then the D value is 38.5. The next two questions have to do with different qualities of the graph. According to this model, what is the range in temperatures the chemical reaction will include? So that's talking about the minimum and maximum Y values. So when we find our min and max, we always start from the midline, which in this case is 38.5. For the minimum, I'm going to subtract the amplitude, and for the maximum, I'm going to add the amplitude. So that gives me a temperature range. My minimum is 34.6, and my maximum is 42.4. So the range is 34.6 degrees Celsius to 42.4 degrees Celsius. The next problem says, according to this model, what is the time it takes for the reaction to complete one full cycle to the nearest tenth of a minute? So this is really a question about the period of the function because it says one full cycle. So using the formula 2 pi over b, if I look at my regression, the b value, the number in front of x, is 0.4. This wants it to the nearest tenth, so I can just type that in my calculator, and I do get 15.7 minutes. Looking back up at the graph or the table, I see that I have a 35.7. It goes through the cycle and is about at the same spot at 16. So this shows me that that 15.7 looks pretty good for what the period would be based on the data.